Hey, welcome back. Hope you had a great day. We spent today expanding logs, and now we're going to talk about condensing logs, which means you take um, a sum of logs or a combination of sum and difference of logs, and you condense them down into a single log with one combined input. That's called condensing. And then we're also going to use the change of base formula. So I'm not going to go through these properties again. You want to start training your brain to look for them. They'll help in the simplification process. They'll help to get you to a single log if you can work the other way. So we're going to condense using the product property, and we're just going to look at it from the other perspective. If I have two logs with the same base, and I am adding them together, then to create a single log, I have log in that same base of the product of those inputs. We're just going the other way, the product of those inputs. So on number 1 here, this would be log base 4 of 5 times x. 5x is my input. Number 2 would be log base 3 of the input x times y times z. Number 3 would be the log base 10. It's base 10 because there isn't a log specified, so we know automatically it's base 10 of 3 times 2 is 6, x, y. I just multiplied my numerals together, put my letters in alphabetical order. We can also use the quotient property in the other direction. So if you have two logs, or even more logs than 2, and they're in the same base, and you are subtracting them, then you can write it as a single log in base b, written as the quotient of those two inputs. You do have to be careful that the numerator is the quotient of the first term and the denominator is the quotient of the second term. It cannot go the other way. So if I want to condense log base 3 of the input x minus log base 3 of the input z, this can be written as a single log, log base 3 of the input x divided by z. It cannot be z divided by x, it must be x divided by z. The second example, log base 4 of the input 5 minus log base 4 of the input x, can be written as a single log in base 4 of the input 5 divided by x. So why don't you try your video question and see how you do. The last property is the power property, and it says that if I have a coefficient out in front of a log being multiplied by the log, then to condense it, I can move that coefficient back to the power position. All right. We don't always use this property. Sometimes, particularly when we're solving, we will divide through if we have an equation, but it's good to know where it came from. So if I want to condense 5 times log base 4 of the input x, that's going to be log base 4 of the input x raised to the 5th power. Number 2, 2 times log base 3 of the input 2x can be rewritten as log base 3 of 2x squared, which you could also write it as log base 3 of 4x squared, like so. And then the final example here, this would be log base 10 of the input 3 raised to the 2x power, right? Why don't you try your video question, and then we'll go and we will use these with more than one property at a time. All right, here we go. Remember to mark down any questions that you have. If you get a video question incorrect, please mark it down so that we can discuss it tomorrow. So here's just some helpful hints. I gave them to you when we were expanding. Now we're condensing. Move your coefficients up to your exponent, especially if you don't have a equal sign, which we won't today. Rewrite your integer terms, like if you have a number 1 or a number 2. Write them as a log of the matching base and the input. That's what 1 equals. If we had 2, that would be log base b of the number b squared. Okay. Multiply all your inputs of positive terms. So if you have a positive log and another positive log, then those inputs will be multiplied together. If you have positive logs and negative logs, then you'll multiply your positive log inputs together, and you'll move your inputs of your negative logs into the denominator. Then we're just going to simplify any rational numbers and inputs to their simplest form. Let's do a couple. 1/2 times log base 2 of x. Well, that can be rewritten as log base 2 of the input x raised to the 1/2 power. And if you wanted to, you could write it as log base 2 of the square root of x. Okay. Number 2, move your coefficients to the power position first. Log a squared, that's base 10 of the input a. Let me just make that so that it reads a little bit better. This is log base 10 of the input a squared plus log base 10 of the input b cubed minus log base 10 of the input c to the 4th. Now, any positive logs, the inputs get multiplied together. So that's log a squared b cubed. Any negative logs, the input gets moved to the denominator, c to the 4th, just like that. All right. Here's an example on number 3 where we have a 1 as a term. So I'm going to write it as log base 10 of 10. Log base 10 of 10 plus, now for the second term, I'm going to move my coefficient up to the power, log base 10 of u to the 4th, and then minus log base 10 of n squared. Now my positive logs, I'm going to multiply those, so I get log base 10 of 10 u to the 4th log base 10 of 10 u to the 4th over n squared. For this final one here, my 2, I'm in log base 3, so 2 is going to be log base 3 of the number 3 squared, which could be 9, plus log base 3 of 4x to the 3/2 minus log base 3 of y squared. And now I'm going to simplify. So this is log base 3 of 9 plus log base 3. Now I'm going to think about this. The square root of 4 is 2, and 2 cubed is 8, so that becomes 8x to the 3/2 minus log base 3 of y squared. So I'm going to get, log base 3 of 72. Oof, just too tight for me to fit in here. 72x to the 3/2 over, oh, I can't even read that. I'm going to go. I don't even know where to go. Okay. I'm going to go. Sorry, I'm wasting your time here. All right, I'm going to go up here. It's going to be log base 3. 9 times 8 is 72. X to the 3/2 over y squared. And again with that stinky old line. Okay, there's the final answer for that one. All right. Try these as your video questions, and then come on back and we'll start talking about change of base. All right, this is going to be log base 4 of the number 5 plus log base 4 of a to the 1/3. So now I can start pulling them together. So log base 4 of 5a to the 1/3. Number 5, this is going to be log base 7 x squared minus log base 7 y to the 12th. And then that's going to become log base 7 of x squared over y to the 12th. Number 6, we're in log base 8. So this 2 can be written as log base 8 of the input 8 squared plus log base 8 x squared. And now I can use my product property, and I'm going to convert 8 squared to 64. So I get log base 8 of the input 64 x squared. Okay. Now let's talk about a change of base formula. I have included the how it works on slide 11 of this set. But notice what's happening here. Let me read this out. If you have a log base b of an input m, okay, we can write it in log, any log actually. Our two frequent ones are log base 10 and natural log, because we can easily get decimal approximations. So what we're going to do is we're going to take log base 10, or we could take ln, log base 10 of m divided by log base 10 of b. All right, so why don't we do log base 10 here, and then I'll show you later on this week how to use ln. Okay, using a calculator and the change of base, estimate the log values to 3 decimal places. So this is going to be log base 10 of 8 over log base 10 of 5. And notice that this is not the quotient property. Notice that I'm taking a log and I'm dividing it by a log. So you want to be careful to close off those parentheses in the log. So I'm going to hit log 8 and that parenthesis, hit the division sign and hit log 5 and hit that end parenthesis, and I get 1.292. All right, so sometimes we can condense them first. So this is log base 21 of the input 35. I multiplied my two inputs together. Now I can estimate it by going log base 10 of 35 divided by log base 10 of 21. All I did was condense and then use the change of base. All right, and when I do this, I get 1.678. 1.678. Number 3, we are going to condense. So look, I'm in log base 3/4. So this is going to be the same as log base 3/4 of 50 over 10, which is equal to log base 3/4 of 5. So I'm going to take log base 10 of 5 and divide it by log base 10 of 3/4. Be careful with your parentheses, very, very careful with your parentheses. And you should get negative 5.595. All right. Okay. These are the problems that we're going to work on tomorrow in class. And then if you want to peruse the change of base formula and why it works, there it is. Thanks for listening, and I'll see you tomorrow.